All right, let's jump right into this explainer. We're going to review absolutely everything you figured out in lessons 7 through 13 to build the ultimate storm building toolkit. You guys have done the heavy lifting, investigating all these crazy weather patterns, and now we're going to organize all that hard-earned knowledge so you can totally crush your upcoming hurricane assessment. Seriously, think of this as your master study guide, brought to life.
Here is the game plan for today. We're tackling this in 5 steps: getting water into the air, making clouds appear, convection and moving air, building our storm model, and finally acing that hurricane assessment.
First up on the list, Section 1, getting water into the air.
So to build a storm, we obviously need raw materials, right? You kicked this whole journey off by looking at these massive dark clouds and extreme hailstorms. You were trying to answer what seems like a simple question. Why does hail, rain, or snow fall sometimes, but not other times? Well, you quickly realize that to get precipitation to fall out of the sky, you first have to figure out how it gets up there in the first place. I mean, you can't exactly have a rainstorm without water in the atmosphere.
You totally nailed this by looking at energy inputs. Your models prove that sunlight provides thermal energy, and that warms the water right there on Earth's surface. When that thermal energy enters the system, it causes the liquid water particles to speed up and space out. Eventually, they get so energized they just break away from the liquid state and evaporate into the air as water vapor. It's a completely invisible gas, but this kind of ghost-like vapor, that is the absolute critical first ingredient for any weather event.
Okay, moving right along to Section 2, making clouds appear.
Now that we've got our invisible water vapor floating around up in the atmosphere, think back to that cold gel pack interacting with warm, humid air in your classroom experiments. You figured out that when you cool the air down, the water vapor inside it literally changes state. You watched condensation form right before your eyes. This happens because removing thermal energy causes those fast-moving vapor particles to slow down and clump right back together. So, the crucial point here is that, as warm air rises higher up into the atmosphere, it hits cooler temperatures. This temperature drop forces the water vapor to cool down, slowing those particles until they condense into liquid droplets or, if it's cold enough, solidify into ice crystals. But, they don't just float there all by themselves. In Lesson 9, you discovered that these droplets gather around tiny little particles of dust or ash suspended in the air. When enough of them clump together on that dust, boom, they form the visible clouds we see in the sky. Which brings us to Section 3, convection and moving air. So we have our water and we have our clouds. But what keeps this whole process moving? What pushes those clouds higher and higher to form those intense, towering hailstorms? In Lesson 12, you did a really clever investigation to figure this out. You used water as a stand-in for air to test fluid dynamics, because we know both gases and liquids behave as fluids. By observing how warm and cold water interact, you proved that warm fluids are less dense, so they rise, while cold fluids are more dense, so they sink. This happens just because the particles in warmer fluids are spaced further apart, making them lighter than the tightly packed particles in the cooler fluid around them.
And this brilliantly illustrates the invisible engine of convection. Convection is exactly this cycle: warmer, less dense fluid rising, and cooler, more dense fluid sinking. In the atmosphere, this acts like a massive vertical elevator. The rising warm air pushes up on the water droplets and ice crystals, literally holding those heavy hailstones aloft inside the cloud. It lets them grow larger and larger until they finally get too heavy for the updraft and crash back down to the ground.
All right, Section 4, building our storm model. It is time to pull out the ultimate scientific cheat code. You haven't just been learning random facts all unit. You've been tracking these individual mechanisms on your charts and progress trackers and linking them all together. And together, they form a complete causal model that basically unlocks the answers to almost any weather event on Earth. Look at this chart from your class. These are the essential rules of weather that you built and agreed upon based entirely on your own hard evidence. This is your gotta-have-it checklist, and let me tell you, it is your master key for your assessment. To explain a storm, you gotta have these 5 steps. First, energy input, where sunlight warms the surface. Second, density changes, where that warmed air becomes less dense and rises up. Third, cooling, because air temperature drops the higher up you go. Fourth, condensation, where that cooling air forces water vapor to condense into clouds. And fifth, convection-driven lift, where the rising air pushes up on those droplets and crystals until they are just too heavy to stay up there. Honestly, take a moment to just appreciate this. You figured out every single one of these complex mechanisms through your own hands-on investigations.
From watching those gel packs sweat to tracking fluid dynamics in water tanks, you built this model from the ground up. That is a massive scientific accomplishment. You are absolutely armed and ready.
Finally, Section 5, Acing the Hurricane Assessment.
So let's take your completed Gotta Have It checklist and apply it directly to your summative assessment. Your task is to step outside that local hailstorm and apply these exact same models of energy and matter transfer to a much larger scale weather event, a hurricane.
Now, I know it might seem intimidating because a hurricane is hundreds of miles wide. Taking tests is stressful enough without throwing a Category 5 storm at you, right? But remember this, the laws of physics do not change just because the storm got bigger.
To ace this test, you just need to lean on your cheat code. Start by identifying where the thermal energy comes from. Hint, think about that warm ocean water. Then, trace the path of that water as it changes phase from a liquid on the surface to a gas up in the atmosphere. Explain the massive convection currents driving the movement of that air and water upward. If you rely on your Gotta Have It checklist to connect the causes to the effects, step by step, you are going to have a perfect, scientifically sound explanation. You've got the tools, you have the causal model, and you totally understand the particle science behind it all. So as you walk into your assessment, I'm leaving you with this to ponder. How exactly will you use the invisible engine of convection to explain not just a falling hailstone, but the massive, rotating fury of a hurricane? Trust your evidence, trust your models, and go crush that test.